Hey everybody, and welcome back to my channel. Hope everyone is doing well today. So let's pick up where we were. I'm going to turn off this fretboard fixture and head over and turn on the fretboard blank. And we need to roll this upside down and then head over here to the manufacturer. And go ahead and create a setup for this blank. Start over here and call this the Fretboard Blank. And in the notes I'm going to put here bottom up, just so I don't forget to put the blank on upside down. Work offset's going to stay at the G56 number 3. And then for the stock, we're going to go ahead and put that back to a fixed size box and bring the round up to nearest value down to 0 again. And then you can see stock point I want is going to be here on this point up here. And we're going to change this. Flip that over and that should be where I want it. And click OK on that. And then we're just going to do a hole operation, drilling operation. And for my tools, I'm going to go down here to sample tools and inches, turn on my milling tools, and I'm going to grab a 1/4 inch flat end mill. Change here to my geometry tab. I'm going to select these 2 holes. And then for the heights, I'm not going to put that bottom height in there. It would actually drill all the way through the piece. So and I'll leave this as a wrap it out. And just zap those little 1/8 inch holes in there. And click OK on that. And then I'm going to save this Fretboard Blank, Mach 4. And post this. And again, remove my X0, Y0. And I'm going to delete all of this that I just did. And I'm going to go in here to my models. And I'm going to turn off the blank and turn back on the fretboard. Oh, that's not quite ready yet. So let's head back over to the design. Turn off the blank and turn on the fretboard. Put it back to the home view. So I see we still don't have these radiuses back here. I took those out. So go to your fillet tool here and click on these 2 lines here and give it a value of 0.125. Click OK on that. And then up here I want to get rid of this fret slot. So if you scroll back from the end here to this last combine move, you can right click and suppress the feature, and that'll bring our nut back, and you can just turn that nut off, and this will do. Now we can head back over to the manufacturer, close all this up and create another new setup. So here it's going to be about the same. I'm going to throw a bonus in here though. And we'll just call this one Fretboar Binding. And we'll take this again to our G56 offset. And then here, for the stock, instead of relative size or fixed size, we're going to go to from solid. Click on here and then open up the models and choose the Fretboard Blank. And then our first tab here, box point will be back here. And that looks good. Click OK on that. Now I'm going to throw a little bonus in right here. And we're going to cut a binding channel around this fretboard. Yeah, so we can add some binding to it. So the first thing I want to do is close all this and just do a 2D contour. And for the tool selection, I already had this open previously, so I went down here to these sample tools in inches and then make sure that the milling is checked over here. And then I scroll down here to a 1/8 inch flat end mill and select that one. And then here for the geometry, I'm going to go down here to the bottom and click on this line down here, and it goes all the way around. And I'm going to hover on that line until it turns red, and I'm going to left click and hold and let go. You'll get some options here. First we want to check this open contour. Now you see it deselected everything except the line we were hovering on, so be sure don't hover on this front line. Hover on one of the long side lines. And then you just go around and select the lines that you actually want to cut. So I want this one, and that's it. Basically we do not want this front line. Then down here you have to click the plus to accept this cut right here. And these are fine here. I'm going to go ahead again. I'm going to put the bottom height. I'm going to actually use the stock bottom here. I don't think that's necessary, but it's just for my own sanity. I like to see that it knows a dimension for how deep it's going to cut. My tolerance I'm going to lower again, 0.001. And this is all pretty good in here. I am going to use this both ways here. And then down here, click on multiple depths. And I'm going to give it a value of 0.125. It's 6 millimeters is a little bit too much for a 1/8 inch bit to cut through in one pass. Guess you went slow enough, it would be okay if it's a new bit. And then here's where we're going to put in the binding. Click on this stock to leave. Now the radial stock is how far out this direction from the model, and the axial is how much deeper, which would be in play if we were cutting this slope right here. You could put a value in there to stay further away from that slope or closer to that slope. So for the axial, we actually leave that at 0 or put that to 0. And for this one, I'm going to do a negative because I want to take away stock. I don't want to leave stock. I want to take away extra stock. So it's going to be negative 0.06. And that's just shy of 1/8 of an inch, which is how thick my binding is. So you don't want to do it the exact thickness of the binding. If your binding has any thin spots in it, then you're not going to be able to sand it flush to the neck. So you don't want it quite as thick as the binding is. You want to leave a little bit in there for sanding, and that should be fine for that. Turn on the smoothing, and that'll bring down this new tolerance down here. Then over here for this linking, pretty sure you can leave everything where it is. I'm not going to use any ramp moves in here, and these entries are coming in from the stock, so it's not going to mess anything up. That is one thing to watch with this program. I'm going to click OK on that. See how these entries are coming in here. They're just going in and digging down into this piece over here, and then very quickly at maximum speed it's going to jot into the job and go over. Sometimes that doesn't work out so well. Sometimes it runs into work that you didn't really want it to run into, so you'd have to turn those entries off, in which case it would either plunge directly straight down into the cut, or you could set up those ramp moves and it will ramp into the cut. Anyway, you can see in essence what we've done here. That gray that you see left over there, that is the extra cut that we're cutting into this fretboard, and you'll see that is actually what we will fill that back in with binding material. And so we're good for that. If you want to see it run, we can check that out real quick. Turn your stock on here and hit the play button. Mine's going real slow here. Speed it up a little bit, and it'll run around a couple passes. And then you can close this, and we'll go ahead and post this. Mach 4 fretboard binding, and post that. And the file's getting a little bigger now. Go ahead and take out this homing. Save that. Okay, and while we still have this up here, you can use the same setup as we have now. Just get rid of this contour. And let's go here to the 3D menu and select this parallel. So tool select. And on this one, I'm going to go back to the sample tools and inches. I'm going to scroll down. Now the biggest ball nose I have is a 1/2 inch. And that's what I'm going to use. Now do see they both have the bull nose and the ball nose. Don't get confused in those. It's two entirely different bits. Select that. Then go to the geometry. And then you can again just click this bottom boundary, and it will cut everything that it sees in that boundary. And then passes here, I'm going to take my tolerance down again. And then this step over here is how much sanding do you want to do at the end of this, and how much wear and tear do you want to put on your machine in cutting this. I'm going to do mine about a 0.05 step over. And there's still, that'll be just a moderate amount of hand sanding to finish that smooth. Of course, you will need to also cut yourself a radiused sanding jig to do that, or a sanding block to do that, which at this point in the video you should pretty much know how to get that accomplished. Or take a 2x4 block and put a 12-inch radius cut in it, the same as we did for the fretboard. And then glue a piece of sanding paper in there and use that to sand this curve, this 12-inch radius. Let's see here. Direction is both ways. Don't need multiple desktop. Turn the smoothing on here. And then all this should be fine the way it is. We'll see how that looks. Okay, that's running the length of my board, and that is what I want it to do. And it's not waterfalling too badly. It's not waterfalling at all. And if you don't know what I mean about waterfalling, if you tell the machine to cut over the boundary, the machine will dive over the edges. I'll show you what that looks like here. If I were to edit this and go back here to the geometry, and instead of this tool containment being to tool center, so that the tip of the tool stops at the boundary, and we'll tell it to go to the outside, the entire tool will go to the outside of the boundary. And you see what you get is this waterfall effect. You can tell it most here on the sides. Let's look at it straight down the right side here. It cut down on these sides, it dropped down, and that for me is not desirable for it to do that. And you can tell it even more so if you were cutting in the other direction. So let's go here and edit one more time. Now if you do want to cut it in the other direction, I want mine to cut in this direction because that axis only has one motor, so there's less wear and tear and less chance of something getting out of step, which is almost zero anyway with the motors that I have. But if you have just regular stepper motors, then running two motors to make that many passes, the chances are better than zero that one of your motors is going to get out of step a little bit by the time you get through with all that. But if you wanted to cut it in that direction, the opposite direction, you just simply go back to this passes here and change the pass direction right here to any value you want. You can cut them in any direction you want, but keep them running in a perpendicular line or a parallel line. I'm going to use 90 degrees. Click OK on that, and so there you can really see the waterfall effect, they call it. It dives over the edges, but you can see you can set it up to cut in any direction you want. In here, if we turn the bit containment, tool containment back to tool center line, click OK, that'll hold everything up on the stock and only take away what it actually needs to cut. And there again, I'm going to turn mine back the way it was, to be cutting down the long side of the part. And that's the way I'm going to do it. Go ahead and post that. I'm going to change this time. This is the wrong folder. This needs to be in my fretboard folder. And post that. And now we're really starting to get into some G code. Okay, and again I'm going to delete all this stuff. I'm going to head back over here to the design, and I'm going to turn back on my nut. Actually, I don't have to turn the nut on. I'm going to go back to this. Just make sure you're at the end of the design, and look back here to this combine that we suspended or hid before, suppressed, and unsuppressed that feature. And then also I'm going to turn on my fret slots, and then head back over to manufacture. Then we'll go ahead and do a setup on this. And I'm going to call this the nut slot, and I'm going to use that solid again. And box point will be down here. Click OK on that. And for this one, I'm going to use the contour again, 2D contour. And I'm going to use the 1/8 inch flat end mill. And I'm going to cut this line and this line. And this line. And I'm going to hover and click here, and I'm going to make that open. And just that one line is all I want. I'm going to say good for that. And I think that's all we need on this. Change the smoothing tolerance. Turn the smoothing on. Shouldn't need multiple depth on this one. And click OK and see how that looks. Good. That should cut that out. And this, we don't have to worry about this thick material right here because it will already be gone from this bull nose we cut earlier. So I'm going to save that, post that over here. Fretboard, slot, nut slot, post. Okay. Oh, sorry, I'm talking to myself here. I'll try to avoid that. And I'm going to get rid of that. Keep that set up. Get rid of this. Okay, now I want to cut these fret slots in here. And for that, I'm going to go to the 3D menu. And I'm going to use this project strategy. And for the tool, I think I'm going to have to make the tool. It doesn't really exist. So I'm going to click on this add button right here, or new tool, this plus sign up here. And it is a flat end mill. And I'm going to call this the fret slot cutter. And I'm going to take my calipers and measure my cutter here. And it is a 2 flute carbon. And the diameter is 0.5 millimeters. And the shaft is 0.125 inches. It's 1.5 length. And the length below shoulder is 0.8. And the shoulder length is 0.3. And the cutter is 0.1. And it doesn't look exactly that way. The shoulder is actually tapered here. Select that one. And then the geometry, curve selection. Select all these lines here. Tool center. Avoid touching, that's fine. Bring the tolerance down. Now, this direction for this little teeny tiny tool both ways is going to break your bit, possibly. I'm down to my last few bits. I went through a 10 pack pretty quick. Now because we cut a binding channel in here, the bit is actually going to exit, so we might be able to get away with cutting in both directions, because it's actually going to leave the stock and then come back in. If you didn't have the binding, it would almost certainly break the bit. If it doesn't fully leave the material and change the direction, it snaps it right there almost every time. So just on the safe side, that's just a slow process anyway. I just creep that bit along. I'm just going to put one way on here. And then the axial offset will be how deep you want to cut those slots. Okay, so you can see his tangs are 1.88 millimeters. You just call that 2 millimeters and leave a little space if you want to use some glue. So axial offset, I'm going to put 2 millimeter. And then we will do multiple depths and number of step downs. Leave that at 1. And maximum step down will be 1 millimeter. And turn on the smoothing. And let's see what that looks like. Okay, you see what I've done here. I put the axial offset in a positive value. So the actual offset needs to be a negative value. And we'll just change this axial offset here to a negative value. And click OK on that. And now if we go up here and turn on the simulation here, we can run that and you can see that it makes 2 paths. Now looking at it at this angle, you wouldn't know if it were actually going straight back across or at the diagonal at this point. You'd have to kind of tilt it up to take a peek at it, but there's a second cut. And that should do it. See, for instance, right now, if you look at it, it's actually going diagonally. So to be aware of that when you're looking at it straight on from the end. And it's on the 2nd fret now. Yep, looks good. Go ahead and post that. And because we didn't change the setup, we need to change the name here. Fret slots. Fretboard document. Post that. I think we have all we need to cut a fretboard. And go ahead and save this and head back out to the CNC and see what we can do outside. Alright, thank you guys for watching. God bless you all. Hope you're staying safe out there.